convolution codes. Yeah, I will explain some of the numerical problems on the convolutional codes. For example, for a 2 comma 1 comma 2 convolutional encoder with G1 1 comma 1 comma 1 and G2 is equal to 101. For this given encoder, draw the encoder diagram. Find the code word V for the information sequence U is equal to 10011 using the time domain and transfer domain approach. Yeah, this will describe the connection details of the encoder. Based on this, we have to draw the encoder. And the next step is find out the output sequence, that is encoded sequence generated by this encoder. Yeah, based on this uh, given values, like n, usually encoder is represented as n comma k comma m, n k m. N is equal to number of outputs and number of inputs, and m is the number of memory registers, that is the flip-flops. So this description will give the some information. Means this encoder is having two registers, one input and two output. Means two flip-flops are required, two output, two XOR gates are required, and there is only one input. And how these flip-flops and XOR are connected, that will be decided by this connection details, like output 1 like 111, output 2 like 101. Yeah. So summary is it has of two registers, one input and two output. Yeah. This is the encoder. These are the two flip-flops here and two outputs. Means first we have to place two flip-flops one by one. And it has a two outputs. So two outputs of two XOR gate. Then connection details for the output one. So 1, 1, 1. So this is a one connection. And output of the first flip-flop, that is a 1 year. And the output of the second flip-flop, that is also given. Coming to the second output, this first input and 0 means flip-flop 1 output, there is no connection here, and the flip-flop output, okay, that is a second register, that is the connection. So this is about the encoder diagram. Coming to the second part, we have to find out the output sequence, means encoded, these V1, V2. Combining these two, we have to write the encoded message in time domain as well as transform domain. Time domain approach, the input sequence is 10011. And first we have to write the generator matrix for the given sequence. And matrix usually defined by number of rows and columns. Number of rows of matrix depends upon this message length. You will call it as a L. And columns, that is n into L plus m, where L is the length of the message, output, and memory register. Yeah. Its length is 5 into n is 2 outputs, L 5, m 2. That is 5 into 5 plus 2 to 7, 14. Means number of rows are 5 and columns are 14. Yeah. G1 is 1111101. Matrix. How to draw the content of this matrix? This is 1 Yeah, 1, 1, 0, 1, 1. Yeah, the first element here, 1, yeah, 1, 1. Next one is 1, second G2 connection is no connection, C. 1 is here and 1 is. And total 6 columns, okay, we filled up. 14 minus 6, remaining 8. Simply place zeros or make it as a empty also. Coming to the second row, just okay, shift it right. Shift it right, and this will be filled up by a zeros. Similarly, third row, fourth row, fifth row. So at the end of the shift, this 1 1 1 0 1 1. This is about how to write the generator matrix. That is 1 1 1 0 1 1. Remaining 8 because 14 columns are the 6 0 0. Next, simply shift it. Okay, 0 0. Next, right shift it 1 1 1 1. Next, okay, 2 times shifting. In this way, we have to first write the G. Next, encoding operation. U into Z. U is 1 0 0 1 1. This is the generator matrix. 5 elements. Yeah. This is a 1 cross 5 here. Okay. Yes. This is 5 cross 14. 1 into 1. Yeah, 1. Next 0 into 0. 0 into 0. Like 1 into 0. 1 into 0. Summing up this one, it is a 1. Similarly, for the second column, 1 into 1, yeah, remaining are all 0, 0. 1 into 0, yeah, 1, 1. Next, third column, 1 into 1, yeah, 0 into 1, yeah. These are all 0, 0, 0 here, okay, 1. Fourth column, 1 into 0, yeah, this is 1 into 0 actually. Yeah, 1 into 0. This should be 0. Yeah, it is a 0. 0 into 1, 0 into 1, like 0. Similarly, we can do, and final answer is 1 1 1 0. And next, like this, okay, we did it for this remaining. We are getting a 1 1 0 1 0 1 1 1. This is the coded message in a time domain. Transform domain, G1 of D, it is a 1 1 1. We can write it in terms of transform domain, that is polynomial wise. 1 1 1 means 1 plus d square. G2 of d is 1 0 1 1 0 d plus d square. And the given message is 1 0 0 1 1. In terms of polynomial, 1 d is 0, d square is 0, yeah, d3 d4. This is about message G1 and G2. First path output, that is a C1 of D, G1 of D into M of D. 1 plus D square, 1 plus D3 D4, 1 into 1, 1 D cube D4. Next D plus D to the power of 4, D to the power of 5. D square, yeah, D square, D to the power of 5, D to the power of 6. Next, we have 1, D is here, D square, 3, 4, 5, 5 2 times. Yeah, 1, D square, D3, D4, D4, it is repeated 2 times here. And D5, D5 also, D6. Yeah, remaining is, means these two will be XORing. Okay, D4 and D4 is XORing. or these two will be cancelled out. And d5, two times it is here cancelled out. Remaining is 1d, d square, d3, d to the power of 6. In terms of binary, 1, 1, 1, 1, 5, it is not there. Yeah. 4 is not there, 5 is not there, 6. Means 1, 1, 1, 1, 0, 0, 1. Similarly, the output for the second path is 1 plus d square into 1 plus d3, 4. 1 d cube d to the power of d square into d3, d5, d2 into d6. Yeah, 1 d square d to the power of 3, 4, 5, 6, 1, 0, 1, 1, 1 here. So both the codes were written here. Then 1, 1, yeah, 1. 1, 0, yeah. Next 1, 1, like 1, 1, 0, 1, yeah, 0, 1. 0, 1, like 1, 1. This is the way you can write like this.